The Summa Perfectionis Magisterii, Part 3, a short essay by Bruce Mills, otherwise known as the Skeptical Alchemist, working from the Newman Critical Edition. For those who came in late, the Summa Perfectionis Magisterii is a book published in Latin in Europe in the early 14th century. Its topic is classified in the 21st century as alchemy. Alchemy is said, in the 21st century, by many commentators, to be the pseudo-scientific precursor of the scientific chemistry. Some go as far as to say that it was mystical mumbo-jumbo from which we finally extracted ourselves after 1,000 years of darkness to the renaissance of science and a new golden age for all the humans on the planet. This view was helped along by several factors. Firstly, just as in the 21st century there is scientific quantum theory and mystical quantum theory, there was in the 17th century scientific alchemical theory and mystical alchemical theory. The bulk of the mysterious cryptic books with riddles, symbols, and pictures of queens bathing naked in the lake came not from the long and venerable history of alchemy back through the cultures of the Arabs, Romans, and Greeks, but from the fertile imaginations of Europe of the day. It is not my task in this essay to object to the mystical interpretation of either alchemy or quantum theory. I might object some other place, some other time, but not in this essay. This essay, and each companion, is a discussion of alchemy taken on face value as a science to which the names chem, alchem, alchemy, chemistry, and finally chemistry have been given over the centuries, all part of the class of microscopic theories of matter. Although I am not entirely incapable of reading the original medieval Latin, I am also not entirely capable. So I have chosen to follow the translation in the Newman Critical Edition, the translation of the Summa Perfectionis of pseudo Geber. The reader is directed in the direction of Newman, as well as the available Latin copies of Summa, for further depth on this topic. I have also made it clear to myself just how questionable my Latin speaking is, and so will not subject anyone to any further attempts in this direction. Well, almost not. One of the first things that people would be told in the historical legends in the 21st century textbooks on chemistry about the ancient art of alchemy would be that the alchemists relied on magical incantations to try to transmute lead into gold. And any chemist will tell you that they were woofing up the wrong bush on that one. It is not possible, since these are distinct elements, and any quick trip to the laboratory bench would show that immediately. But this is not so. Firstly, it is known that the elements do even spontaneously transmute from one to the other by nuclear reactions. In some cases, elements can alternatively be coerced by bombardment with neutrons, protons, electrons, and helium, to split apart and recombine as new elements. And those particles can be provided by the elements that spontaneously change. Hence, the use does not fundamentally require high-tech or sophisticated theory. And there starts a long argument that goes to and fro and down the garden path on the scientific status, pre, proto, or pseudo of alchemy. This essay, however, begins mainly from the idea that alchemy is older chemistry and a science to boot, but not to boot out. Also, alchemists were not only interested in the manufacture of artificial gold, but also in dyes, inks, explosives, acids, and other materials of general industrial or military use. To explain alchemy in terms that will emphasize the mundane rather than mystical threads, I often make analogies between 14th century alchemy theories and 20th century chemical theories. The emphasis is on the idea that they are variations on some themes that have been with the study from the start. One of those is the infighting between the continuum theories and the atomic theories. This dichotomy seems to have been finally resolved by the quantum theory asking, why not both? But a more detailed technical analogy starts with the naive modern theory of chemistry that all material is made from atoms and atoms are made from protons, neutrons, electrons, and photons. The photons are the bosons that carry the electrical forces that keep the atom together. This can be mapped merely as a rough analogy to the four classical elements of earth, water, air, and fire. Those elements are much more the concepts of solid, liquid, gas, and plasma than they are really intended to be specific materials in the modern chemical or particle sense. Empedocles stated that these materials were pulled together by love and pushed apart by hate, which sounds very mystical and animalistic, until one notes that in the 21st century theory the electrons and protons are pulled together by attraction and pushed apart by repulsion. One can take a specific wording a bit too literally, giving it an anacontextual nuance. The 21st century theory states that these particles are bound together in atoms that are hard to break apart, requiring or releasing large amounts of energy, at least the protons and neutrons. The electrons and photons can be reconfigured to produce allotropes of the elements and to make molecules that are more weakly bound than atoms. The 12th century and earlier theory of alchemical metallurgy contained the principle that there were strong combinations of earth, water, air, and fire, and weak combinations of those strong combinations. So while both sulphur and mercury were made up ultimately as strong combinations, they could not in practice be split up into their prime components, that is, into earth, water, air, and fire, at least not in the extant alchemical furnaces. The furnaces themselves were rather analogous to the 20th century particle accelerators, large expensive pieces of equipment whose main purpose was to increase the energy of the materials, to separate them and combine them, perhaps to make something never seen before. I do not claim here that the medieval alchemists had some ancient wisdom that exceeds the 21st century's best. The development of classical chemistry theory, Maxwell electrical theory, thermodynamics, and quantum mechanics is a marvel of the last couple of centuries, but it was not due to a sudden change of belief from mystical to mundane. It was not due to suddenly becoming scientific. It was a slow but accelerating accumulation of theory and technology in which each generation learned from the ones that came before. As a simple way to hint at the historical period, I will often use the terms ancient alchemy, usually Greek, traditional Arabic or European alchemy, versus chemistry, 1600s, and chemistry, 1700s and onwards. Within this context, the Summa Perfectionis Magisterii stands out fairly strongly because it reads a lot like a 21st century textbook. It says how cool and correct and useful the content will be to the reader. It warns to be cautious and learn properly. It explains in plain language the theory, and it also describes the practice. It reads partly like a laboratory or workshop manual as well as a textbook. It is not obfuscated. It is clear, and it covers the introductory material. The first part of the book warns that the study can be expensive and it requires dedication and intelligence in the student. It even goes into the idea that for workshop practice one needs to be able-bodied. The second part considers arguments against the practice of alchemy by contemporaries. This is something like a book on geography writing an article against the Flat Earth Society. It was important because at the time scientific studies in general were less supported and had to justify themselves, so the book also reads like a grant proposal. We pick up the thread on page 663 of Newman, section 24, Universal Discourse on Natural Principles according to the opinion of the ancients. As before, I will paraphrase and editorialize rather than reading it always straight and complete. The reader should be able to source a copy in case they are distrustful of my reading. Start of quote. We intimate to you, therefore, that the natural principles in the work of nature, according to the opinion of some who were from a sect of those imitating our art, are fetid spirit and living water, which we grant to also be called dry water. And we have divided the fetid spirit, for each is white, red, and black in its hidden part, in the magistery of this work, but each in its manifest part tends towards redness. End of quote. In this context, spirit refers typically to something that is driven off by dry and flameless heat from a substance in a gas or vapour, and then deposited higher up in the chamber where the temperature drops. The body means that which is left after the spirit has been driven off. The fetid spirit, essentially the stinky vapour, would be sulphur or sulphur compound, which are known to be quite, well, fetid. The living or dry water would be mercury. The mercury-sulphur theory of metallurgy was taken up in the medieval Europe from golden age of Islamic states. Mercury was thought to give metals their malleability, and sulphur would give a more yellow colour, such as copper or gold, and a greater stiffness. In more extreme cases, sulphur was thought to provide the friability of certain materials. Much of the time, the exact meaning is difficult to determine. I do not believe that this is primarily from a tendency to obfuscate. For example, the typical modern reader of a modern chemistry book might find a discussion that speaks indirectly about Gibbs free energy and entropy and enthalpy to have a meaning that is difficult to determine. And just as in that case, clarity in the meaning of the medieval alchemical text often comes from broader reading and experience with the context, as well as reading it several times until the voice of the author is finally heard. I go to the idea that the person is speaking in code only as a last resort and only with great evidence. Having said that, what is all that about the white, red, black and manifest tendency towards redness? Background here includes that mercury and sulphur are common impurities in metallic ores. Cinnabar is the main source of elemental mercury, and it is mercuric sulfide, but the mercuric sulfide can be black. Sulphur has a complicated allotrope structure. It often forms rings of 8 atoms, but also long chains. Some people describe it as being only just behind carbon and silicon in the sophistication of its chemistry. In the preparation of vermilion, which is a red dye, originally produced as powdered cinnabar and named for verms, or worms, insects from which similar red dyes were produced, one grinds the material. And it is said that it can start dark and murky, but as it is ground, perhaps days of grinding, it gradually turns red, of better and better quality. That is related to a concept of Geber that metals can have a manifest quality and a hidden quality. Sometimes this is expressed almost poetically as being that within a metal of one quality, the opposite quality exists. I cannot say exactly what that means, but I do know that many times I've been shown that a phrasing that seems odd makes more sense when one actually sees the specific experiment that inspired it. Why the mercury-sulphur theory of metallurgy? Heating several ores can produce a quantity of pure liquid mercury. That may well be the first thing to emerge due to its low melting point. So in heating a metal, one of the first things that comes out is mercury, suggesting that it is a common and important component. And heating iron can give off a sulphurous smell. So both mercury and sulphur seem to be driven off from many metal ores. Also, mercury dissolves gold quite voraciously. As it does so, it becomes less fluid. A similar thing happens in combination of the yellow sulphur with the mercury. Gold did not mean elemental gold in the 21st century sense, nor copper, nor iron. Rather, something shiny and malleable was a metal, and metal that is goldish in colour and relatively incorruptible, did not corrode, would be gold. So it could be a gold-silver or gold-copper alloy. The materials sulphur and mercury in the theory are not elemental sulphur and mercury as called in the 21st century or even the 19th century. On the other hand, they are not, as sometimes suggested, abstract spiritual principles. The main thing is that to interpret this in terms of the classical theory of chemistry with its specific collection of 118 elements is anachronistic and anacontextual. The pragmatic alchemical materials sulphur and mercury were somewhat impure, but exemplified the two principles. The idea of a prime material that cannot actually be isolated as a chunk of material in the laboratory is repeated in the modern theory of quarks. In principle, protons are said to be made of 3 quarks. In practice, it is not possible to isolate any kind of quarkonium to display in a bottle. In a less extreme sense, some materials, such as pure sodium, react strongly and quickly with the environment. And so, much care is needed with a chunk of these, both in the sense of preserving them and in the sense of the danger of handling. So pure sulphur was thought of as something that might not actually be manufacturable, and if it was, it might also rapidly be corrupted by the environment and no longer be pure. Mercury dissolves gold. Mercury and sulphur form red cinnabar, and the most prized gold had a tint of red in its colour. Sulphur, sometimes thought of as perhaps being the principle of fire. The name sulphur means burning stone, as it comes from volcanic deposits and it burns easily. In some alchemical theories, it was closely associated with or even identified as the element of fire. When it burns, it produces sulfur dioxide, which is particularly known for its pungency, though not as much as hydrogen sulfide or rotten egg gas. In many historical cases, elements, when eventually added to the theory post-17th century, were named after these essences and took over the terminology. Material sulfur was no longer seen as an impure version of the pure essence, but as the thing itself, whatever that was. Sometimes this led to the erroneous concept that the alchemists had misidentified the materials that they were working with, or had suggested the existence of reactions that are judged now to be impossible. The meaning of the words changed. One particularly strong point is that they did not mean the elemental materials when they used the terms that are now used in that way. Elemental sulfur and mercury combined to make cinnabar, otherwise known as vermilion, which was known to the Arabs, including Geber and Razi. All matter was also thought of in some theories as being made of the prime materials hot, cold, wet and dry. This was in one sense an alternative theory to the earth, water, air and fire theory. But they were also merged into a single theory by the statement that earth was cold and dry, water was cold and wet, air was hot and wet, and fire was hot and dry. These were some thoughts about the strength and hierarchy of the various materials and interactions. To make gold, one needed the correct sulfur and the correct mercury, and then the correct proportions of sulfur and mercury. Mercury and sulfur are often found in ores. Heating iron makes a sulfur smell. Mercury dissolves gold. Some forms of mercuric sulfide are black. Cinnabar is typically or famously red. Grinding it makes it redder. The Summa Perfectionis Magisterii then promises to explain the nature and generation of each of these materials. It emphasizes that the earthy, aerial, watery and fiery particles cannot be separated in the resolution of these materials. One thing that complicates the analysis here is that I'm reading Newman's translation of pseudo Geber's discussion of the principles of the ancients, and it can become unclear who's asserting who is saying what. The concepts are clear enough in many cases, but the attribution is ambiguous. On the other hand, the general impression of the writing is that pseudo Geber partially agrees with his older sources, but believes that he has a more correct theory, and he will expound that in more detail later. Pseudo Geber then says that others have said otherwise, that quicksilver, mercury, is not its own principle, but is a manifestation of earth, and likewise sulphur. The justification appears to be that mercury and sulphur are not found in their pure form in silver mines and mines of other metals, but only extracted from ores in the alchemical furnace. So perhaps the sulphur and mercury is created by the heating of the other materials, leading to the recombination of earth, water, air and fire particles. Start of quote. Therefore, they are, for this reason, compelled to believe that quicksilver and sulphur in their own nature are not the principle from nature's intention, but there is another, which follows from the alteration of their essence in the root of nature into the earthy substance. The method of this, as before, is that each of them is converted into the earthy nature, and a very subtle vapour is resolved from both these earthy natures by the heat augmented in the viscera of the earth. The double vapour is the immediate material of the metals. End of quote. One mainstream theory of geology in the medieval period was that metals and other materials were created in the interior of the earth at high temperature and pressure, and over a long period of time. The most common objection to the possibility of manufacture of artificial cold was along the lines of merely stating not that it was impossible in principle, but that in practice the temperature, pressure and time required were outside of any pragmatic resources of the alchemists. Sometimes it was suggested that the precise conditions were too exacting compared to the control available in an alchemical furnace. I'm not aware, however, of any medieval writer who objected to the principle of manufacture of artificial gold on the principle that gold was a prime or elemental material. Start of quote. This continues until whatever has been dissolved of the substance in the viscera of the earth and the flowing, dissolving water become one with a natural union. All the elements arrive at such a mixture according to a proper natural proportion, and they are mixed through the smallest particles until they make a uniform mixture. This mixture is compacted and hardened by gradual cooking in its mine, and it becomes a metal. These philosophers are close to the truth, but they still do not conjecture the pure truth. End of quote. The next section is particular discourse about the natural principles of bodies. Start of quote. We have just determined the natural principles of metals in a universal discourse. It remains, therefore, that we now set down a chapter on each one. Therefore, since there are three, namely sulphur, arsenic and quicksilver, we shall add a first chapter on sulphur, a second on arsenic, and a third on quicksilver. Then we shall set down a specific chapter on each of the metals, which are their effects according to the works of nature. Now we must pass to those principles that are the foundation of the magistery, assigning all their causes. End of quote. After this point, the Summa gets down to brass tacks with determination. It has sections on the properties of sulphur, arsenic, mercury, gold, Sol, silver, moon, lead, Saturn, tin, Jupiter, copper, Venus, and iron, Mars. In effect, this is like the periodic table for the medieval period. It goes through the alchemically prime materials from which the others will be created, but also, of course, in preparation to discuss the idea of transmutation. These much more specifically pragmatic matters will be taken up in further parts of this discussion of the Summa Perfectionis Magisterii.